video in the Excel tutorial for macroeconomics. In this third video, we are going to cover the net present value, specifically a calculation of it, including using the Excel solver. And secondly, we are going to look at functions. There are a whole range of different functions built into Excel, and we are going to use condiff, frequency analysis, and some descriptive statistics. Let's start with the net present value. So in this project 6, we are provided with a stream of cash flows, and what we are supposed to do is to calculate the net present value of the project that generates these cash flows. In the case that the interest rate is 10%, 7.5%, and 5%. And then fourth, we're supposed to calculate the same again for the case that the cash flows are reversed. So that opposed to the first case where we get small cash flows in the beginning and large cash flows in the distant future. In the second scenario, we'll get large cash flows in the beginning and they will be decreasing over time. So let's see what our Excel spreadsheet says. So we have these two scenarios plotted here in tables. You see in the beginning we have an investment value of 1,000. That means we need to spend 1,000 to engage in the project. And we can then expect 100 euros in 1 year, 200 in 2 years, and so on. And the story behind that goes, imagine you could buy a coffee bike here in Frankfurt Oder. And buying this coffee bike would require 1,000 euros of investment costs. And if the weather is fine, you stand in front of the university and you sell your coffee, and that's going pretty okay in the beginning. So you expect to earn 100 euros over the first year, and you get this 100 euro in the end of the year. And then where it starts spreading that your coffee is pretty good and more people are going to come over the second year, and the amount of people coming and purchasing your coffee is growing over time. So in year 4, you expect to have a profit of 550. And obviously in the second scenario, which we're going to tackle, the story goes reverse. So you buy this coffee bike and your coffee is really crappy. In the beginning, a lot of students are going to buy your coffee, but as it doesn't taste, the amount of customers decreases over time, and eventually after year 4 you will only have profit of 100. So what we need to do is we need to calculate the discount factor. So we cannot compare 1,000 euros that we spent today with 200 euros that we get in 2 years, because obviously having 200 euros today is worth more than having them in 2 years. So the discount factor is something, let me draw a picture to illustrate what it is actually. So we have a future value, which is the value in, for example, year 2. And you calculate that from some value today, which is the present value. So it's equal to the present value, which is some amount of money that you put in the bank at a guaranteed interest. And when putting it in the bank, it will grow by that interest and eventually be the future value in like 2 years, for example, if you let it grow for 2 years. So we calculate present value times 1 plus the interest to the power of t. So if you give 100 euros to your bank today at an interest of 10%, that is going to grow by 10%, so by 1.1 per year. So if you keep it there for 2 years, that will be times 1.1 to the power of 2. And the discount factor is the reverse thing. So imagine you want to have 200 euros in 2 years. What is the amount that you have to put into the bank today, provided a specific interest rate? So we can just turn this equation around and put the present value on the left-hand side, and that leaves us with present value. Present value is equal to the future value at time t divided by 1 plus the interest rate raised to the power of t. So in other words, if the interest rate is 10% and I want to have exactly 200 euros in 2 years, that will be 200 divided by 1 plus 10%, that is 1.1 to the power of 2, and that yields the present value of those 200 euros in 2 years. And now what we're going to do is we calculate this lower part here. Let me make that a bit more clear. So we can also put the future value aside and say the discount factor is 1 over the interest rate raised to the power of time times the future value. And this first fraction here is the discount factor. So let's calculate that one. We start with an equal sign. 1 divided by 1 plus the interest. And the interest rate is an absolute reference because it is going to be written in that same cell and it's not going to change. So we'll have to fix that cell. So I press F4 to add the dollar signs in front of D and 2 because I don't want D to change and I also don't want 2 to change. Close parentheses. And then I need the power. Let me see if the keyboard here. I have the keyboard here. And for adding a power, you simply add this small roof or the hat, which you find on the left hand side of the numbers. So in the upper left corner of your keyboard, and you press that twice and it will appear 2 times, and then you just delete one of these. And we want to raise this to the power of the time, and we want the time to be located in the same row each time, so we can fix the 4, even though we do not have to, because we're not going to copy the equation or that formula downwards somewhere. And then I'll simply press enter, and obviously the discount factor for right now is 1, because €1 right now is worth €1. And then I copy that same formula to the right. And what we'll find is here, the 0.75, for example. What that means is if the interest rate is 10%, then 75 cents today is equivalent to €1 in 3 years. So I could take the 75 cents today, invest it for 10%, let it grow over 3 years, and it would become €1. And obviously €400 is 400 times that amount. So what we do is we simply multiply the discount factor here by the cash flow in the respective time. So obviously €1,000 today is €1,000. And we copy that equation to the right. So that €400 in 3 years, given an interest rate of 10%, is worth €300 today. So if you put €300 in your bank account, let it grow at 10%, and in 3 years it will become €400. And the net present value of the project is the sum of all present values of future cash flows. So what we do here is we start with an equal sign and then just type sum, S-U-M. And Excel will provide you with all functions that contain sum. And what we want to have is just the formula function sum. And to call that, there's 3 possibilities. So either you just open parentheses to indicate this is the function and I want to head over some parameters to that function. Or alternatively, you double click on whatever function you want, or you press the tab key on your keyboard. So if I do that here, it will just select the first one that is highlighted. Or if I want the second one, I take, for example, the arrow down and then press down. But that's not what we want. We want the sum function. And then the parameters we hand over to that function. I can just highlight these here by holding the left mouse key pressed and highlight all the numbers that I want to have the sum of. And I close the parentheses, press enter, and it calculates the sum. So if the interest rate is 10%, then the net present value is negative 67.6, which means if I had 1,000 euro and I could invest it at 10%, it would be a better investment to just invest it at 10% than invest it in a coffee bike and earn these cash flows. But what if the interest rate is not 10%? So first, let's reformat this appearance of the percentage. You find in the category home, you find the subcategory number, and there's a percentage sign. You can just click on the percentage sign. You may also just use the button on the bottom right corner. I'll press that, and then there's a whole menu full of formatting options. So you can choose percentage with this many decimal places. You can say this is an accounting figure, currency, whatsoever. In our case here, it's a percentage. And we want to have the same calculation for 7.5% interest. So if the interest that, I don't know, your bank account offers is just 7.5% instead of 10, then investing 1,000 euro is basically equivalent to buying the coffee bike for 1,000 euro. Here the net present value of the project is only 0.09 negative, so negative 9 cents. And if you're really a coffee enthusiast, you would still go for the coffee bike. I mean, you could also grab some coffee yourself. And of course, if the interest rate that your bank account offers for the 1,000 euro is lower, then the project is relatively better off. So investing in that project or in the coffee bike would result in a net present value of 75 euro. So we now do the same for the reverse type of cash flow. Again, interest rate is 10%. You can also hit Control 1. Let me show that with the keyword here. So if you hit Control 1, it will open the same formatting menu. I click on percentage to decimal places. Again, I want a discount factor. So what I do, I already created the formula, so I copy it, Control C, Control V, and button F2. And you see I'm still referring to the time in the upper table. So I can just drag and drop this to the time in the lower table. And the same for the interest. You see, if I find errors in all directions, I can just click the left mouse button, hold it clicked, and move this reference cell, which still is an absolute reference. You see that here in the equation. I can move that to the other interest of the second scenario. Now I have the correct formula here. I copy it to the right. Still, you remember 1 euro in 3 years is worth 75 cents today. I multiply the cash flow in the respective time by the discount factor. Copy that equation also to the right. And then I want to have the sum. So again, equal sign, sum, parentheses, all of these. And then the second scenario, even with an interest rate of 10%, the calculation yields a positive net present value of the project. So we did 1, 2, 3, 4. That's project 6, or rather 6A. No, 6B. Let's calculate the internal rate of return. And we do that for scenario 1. Well, again, we're supposed to start with an interest rate of 10%. So what is the internal rate of return? The internal rate of return is the interest rate that your bank clerk had to offer you in order to make you indifferent as to whether to put your 1,000 euros to the bank account at the internal rate of return interest offered by your bank, or whether to buy the coffee bike. So in other words, what is the interest that the coffee bike pays you given these cash flows, or that stream of cash flows? And we could just simply try around and find the value that is close to a net present value of 0, because then the interest, that interest rate here, would yield a project value of net present 0, which is exactly what we need in order to know what is the internal rate of return. But what we want to do is we want to use the Excel solver. And what you do in order to activate the solver is you click on File, Options. Then on the left-hand side, there's Add-ins. Here in the bottom, you find Excel Add-ins, Go, and you activate the solver. So if this box is not checked, then check it and then press OK. And you find the solver in the category Data. On the very right-hand side, there's a subcategory Analyze. Click on Solver, and this is the solver. And by changing the interest, you saw that the discount factor changes, thus the present value change, and finally the net present value changes. And this is what the solver also does. So we have an objective. The objective is the net present value, kind of our target. And what we want to do is we do not want to have it like maximum or minimum. We want to have it calculated the value of 0. And how does it do that? By changing the interest rate. So what is the variable cell? That one. So in other words, dear Excel, please change this cell, the interest rate, until our objective cell, the net present value, gets close to the value of 0. And then we could add some constraints. So you could say the interest rate is not supposed to exceed a specific amount or go below a certain amount. If you specify these conditions, it will just like search interest rate within that range, for example. We don't want to do that. We just want to have like this main objective solved. So now you see here in cell D2 that the solver has changed the interest rate to 7.5%. However, in the formula bar, we see that it's not exactly 7.5%, but it's 7.496981 and so forth. So the internal rate of return is close to 7.5%. And the net present value is close to 0. And you see that from this kind of scientific representation of a value, which tells you that in the 9th decimal place, this value is different from 0. And we can just reformat this by clicking Control 1 or hitting the button in the lower end of the number subcategory in the menu. Both get to the same window here. A menu where we can format a number, and we can make it for decimal places. And then in my case, e to the -9, it tells you that in the 9th place, the figure is different from 0. It could be that it is different with you because the procedure the solver applies is specific to your computer, and it might change at one or the other point, but it will always be close to 0. So whenever you put 2 decimal places, you will see it's virtually 0. So that was project 6. Let's see what project 7 brings us. Here you see just how to activate the solver. We did it already. We used that and we found the internal rate of return. So project 7. We have already used the function sum to calculate the sum of some values. There are a lot of functions implemented in Excel. So there's, for example, there's mean, standard deviation, maximum, minimum, correlation, COUNTIF. You see here the German functions and also the English ones in parentheses. So I'm going to use the English ones depending on the language that your Excel is adjusted to. You may use one or the other one. So what is it that we're going to do? We have a task to use the functions to create descriptive statistics. We're going to use that first. Then we use the function COUNTIF to count the data. We do the same with the function frequency. I show you how to use that and how far that is different from COUNTIF. Frequency is what we call a matrix function. And then finally in D, we're supposed to plot a frequency chart, so histogram, which is supposed to look like this. So let's see what the project tells us. So we have the grades of 20 students for some specific exam. At least we assume that. Grades range from 1 to 4. There are some grades that were not given. For example, I don't see 2.0. I don't see 3.0. In any case, we're first starting off with some descriptive statistics. So the first is the average, which we call simply by the function's name average. Starting with an equal sign, we tell Excel we want to call the function that is called average. I hit the tab or the tabulator key to choose the selected function from the list of functions. And just because I didn't do it in a while, so let me see, I will use the key shortcuts. So I click on the first grade, and then I hold the control key to jump to the end of the section. And I also hold the shift key to extend the range. And then I press arrow down. I'll do that here to highlight or increase the range from 1 to all the way through 4. And then I hit enter, and you see the average of all grades is 2.5. Next, we calculate the standard deviation, starting with an equal sign, stdef. You see some functions have an attention mark here. These are old functions. You can click on them. And these tell you that they're not longer compatible in new versions of Excel. So we are going to use either stdef p or s. And by clicking on either of these functions, you see again a small comment. And what p does, it goes and calculates the standard deviation for a population. That's why we use p. And s is for a sample. So as we don't know the full population of all students that have ever taken this test or exam, or who will ever take this exam, this is just a sample, so we're going to use the standard deviation for a sample. And then again, I click on, say, the last one, and I hit Control, Shift, and the arrow up. And because I don't want grade to be handed over, or this value in cell D8 to be handed over to the function, I hit the Shift button or Shift key and 1 down to decrease the amount of cells in that range. Hit enter and get the standard deviation. I will calculate the maximum and the minimum, which is pretty obvious for the small amount of numbers. I can also click on the 4, hold shift and click on the 1 to extend the range to where I just clicked. And then I have the minimum, which is also which can also be just taken by hand from this small amount of numbers. But imagine you had a million rows or a million lines in your data set, and you wanted to know what is the largest number, what is the smallest number. So these are some descriptive statistics. So whenever you have a data set and you want to describe how the data looks, what is it like? What is the average? What is the median, for example? What is the standard deviation? So you can say what is the distribution underlying the data, and what is the minimum and the maximum, of course. And what I want to show you is the count if function and the frequency function. And the count if function counts how many times each of the elements is in the data set. And to do so, we first have to know what types or what are the elements or the individual uniquely identifiable elements of the data set. So we copy all of this, copy, paste. And then in the section or in the category data in the menu, you find on the very right hand side data tools. And right in the middle there is remove duplicates. We click this. Yes, we want to stay in this column. And we have 8 unique values remaining. And since we need the same values for frequency, I could copy these, but I'll just do it again in case someone of you get lost. So Control C to copy, Control V to paste. Then in the section data here in the menu category data, on the right hand side data tools, there's in the middle remove duplicates. Yeah, we don't want to extend the range or something, just remove all double values, and we have 8 unique values remaining. Not very surprising given that we just did that. Okay, let's start with the count if function. We start with an equal sign. The function is called count if. And now it's pretty intuitive. The small comment tells us which parameters the function needs. So first we need a range where to count something or where to search for the element, and then a criteria. Or in other words, this function counts how often the criteria occurs in the range. So the range is this one, like our data set. And because the range is not going to change, it is going to be an absolute reference to that specific range of data. So I can just hit the F4 button and have all columns and rows in the range fixed and made absolute references. So I then have a comma, and the criteria is, sorry, okay, obviously I don't have a comma, I have a semicolon. The semicolon is also the same in the German version. So in earlier English versions, it used to be a comma. And then the criteria is the 1. So whatever is in the cell left of the current formula cell. And this is a relative reference, or this is supposed to be one at least, because I want to copy that same formula to all the other cells below it. And instead of counting how many 1s are in the range, in the next cell I want to count how many 1.3s are in that range. So I'll just leave it as is, hit enter, and of course I can check that or double check that by just counting. There's 1.1 in that range. Now I copy that and I see there are 2 1.3s in that range, 3 1.7s, and so forth. And just to come back to what we did earlier, I just highlight the whole area where I want to copy the formula with the first cell of my highlighting having the formula inside. And then I press Control D for down. Remember, I think it was the second project, to fill out the empty cells in the range that I have highlighted. So now let's have a look at this formula, for example. So we still say, how often does the criteria, in this case 3.7, occur in that range? Actually, pretty easy equation or a formula function. And a lot of functions in Excel work in that same fashion. So there's a range, there's some search criteria, there is some I don't know, parameter that tells you, or the way you can tell the function if it is supposed to take greater or lower values than the given one. And each function that you use will have such a kind of small help section or comment. And then there are different functions other than these, which are called matrix functions. You can do matrix multiplication, you can invert a matrix, you can transpose a matrix, you can do basically everything with matrices here, because this is a vector. Like, it's a vector of length, what is it? 8. So we have 8 elements in that vector. And what we can do is we can say, this is a vector of elements that we want each to count. How often do they occur in a specific data set? And the resulting vector would also be of length 8. And the first element would tell us that the first element in this vector occurs 1, 2, 3, 4, how many times in the data set. So what we need to do in a matrix function is we first have to highlight the kind of result vector. So we have to tell Excel this is the length or the size of the vector that will give us our results. And while being highlighted, I start typing equal sign, and then the function is called frequency. And it tells you it needs 2 arrays. An array is a fancy programming word for a vector or matrix. So the data array is basically the data set. So what is the data? The data is this here. And we don't have to fix it because we're not going to copy the equation, which you will see in a moment. We'll just stay here and insert the equation at the same time in all of the highlighted cells. Then second, we have a semicolon, and then the so-called bins, which is what we're looking for, like classes or types. And all types or classes or things that we want to count, or kind of the criteria vector, is this one. And before you hit enter, what you want to do is you want to hold the control and the shift button or key. So you hold, let me see the keyboard here. You hold shift and control and then press enter. And if you did that correctly, you see in the formula bar that there are like these weird parentheses around the formula, and you cannot alter one element of the vector anymore. So if I tried that, it tells me you cannot change a part of an array. So you cannot change a part of this like coded matrix. And you see the result is the same as here. So 2 methods, one like usual function and one matrix function. So what we've done so far is we used the functions for descriptive statistics, we used COUNTIF, we used frequency, and now we're supposed to create this chart. In fact, we're not going to let Excel do a histogram, but we are going to do a bar chart using the counts that we counted already. And for this, and for demonstration purposes, I'd like you to click in one cell that has non-neighboring cells. So all neighboring cells should be empty. Otherwise, Excel tries to be smart and tell you what to put in the chart, and we don't want to do that. For like one, I want to show you how to create a diagram or a chart from scratch. And second, should you ever have the circumstances that Excel grabs some numbers and puts them into the chart and you don't want these numbers, I want you to know where to select the data and where to kick some like lines or ranges or something out of the chart that is existing, or where to add new data rows. So what we're going to do is we click in a cell that has only empty neighboring cells, and then in the menu, insert. And there you find a like subcategory that is called charts, and the very first one is column charts or bar charts or however you want to call them. Oh, in fact, column is this one, bar is that one. Okay, so we're going to use column charts. And if you don't have a very good reason, you always want to select the very first one, not the second, not the third, only the first, unless you have a very good reason. And if you have this reason, you know about it. So here you get an empty paper. See, this is the area where Excel will draw the chart then. And right here in the menu, you see two new categories. If you, or like when you have selected this, if I deselect it, the categories will disappear. I can click on it and the categories will appear again. And then if you click on chart design, there's a subcategory data and you click on select data. You can also right click on the, on the empty scratch piece of paper and then click on select data. And on the left hand side, we can add legend entries. So the kind of series that you want to plot, and where you could imagine there's a legend in some end of the chart telling you that color represents this and that. You click on add. We don't need a series name, so we keep this first input field empty, and you delete this kind of empty vector. It gives you a vector of size 1 with a 1 in it, but you delete it because we don't need it. What we want to represent is what we counted, so the number of or the frequency or the number of grades achieved of each type of grade. So this is what we want to represent. And you hit OK. And because we have actual labels for all of these grades, we can say we want to change the labels on the horizontal axis. You find that here on the right side. Click on Edit, and the labels are these. Okay, very good. So now we have a chart that tells us there's 1.1, 2, 1.3, 3 students who achieved 1.7, and so forth. For some of you that might look like this. So you have half students, which doesn't really make sense. So you double click on the labels on the y-axis, and you find access options on the right hand side. So there's a new menu popping up. You can tell Excel what are the borders. We can make it, I don't know, 10, which doesn't really make sense because we have there's no category where we have 10 students, but we could do that. We make it 5. And we don't want half students, so the units, major units, are step 1. We can alter the chart title, results of exam XY. So what you might want to do is you want to have descriptions on the axis to tell people who look at this piece of paper what it is that they see. And in this new category, chart design, on the very left, you can add any element to the chart that is missing and that you feel should be inserted. So you click on that. You can say you want a chart title, which we have already, but we want axis titles. I think this is sufficient because 1, 2, 3, 4, 5 is pretty self-explanatory, and this is grade achieved. So I think that's it. So what have you seen in this video? Let me go back to the first slide that we had today. First, we calculated the net present value. We used Solver to calculate the internal rate of return. So you have seen basic calculations, and you used the first function, which was sum, and you saw how to use the Excel solver. Second, we used functions for descriptive statistics. That was kind of the intro. Then we used COUNTIF and frequency, which was our frequency analysis. And we did that graphically by plotting a column chart and added some labels, texts, and stuff to the chart. Let me know if you have any questions, then write me an email. Otherwise, see you in the next video.